So welcome everybody to our talk Ghost in the Shell. Why do we call it Ghost in the Shell? Because there are really weird things going on in our demo, which should not supposed to happen. So first of all, a few words about us. Me and my colleague Ju are active in the SAP security research community for quite some time. We have discovered a variety of ODAs and reported them. I hope all of them to the satisfaction of SAP and under responsible disclosure. And we're talking about them once SAP has fixed them and some time has passed until all the customers have had a chance to apply the fixes. Yeah, so as you can see, this is not a first conference where we talk about that, but what we're talking about today is new. We have never talked about this before anywhere, except with SAP, of course. Yeah. So before we go into the details of the attack, it is necessary to give everybody an idea, especially everybody not SAP, an idea about how the technology works that we're going to attack. So first, some SAP technology basics. So the first question is, of course, if you're at a conference where there are a lot of people that are not involved in SAP technology, who in the audience is not involved in SAP technology? Funny guys on the left side. Okay, so not everybody knows SAP. So therefore, it's a good idea to introduce SAP and tell people what SAP is. I was at a conference this year in Berlin called IT Defense. And during lunch, a guy on the opposite side on the table asked, "What are you doing?" And I said, "Well, I research SAP security." And then the guy said, "Isn't that a very old protocol?" So he had no idea what SAP was. So he thought it's a protocol. So therefore, it's a good idea to talk a little bit about why we should protect SAP systems. As most of you know, SAP is the largest business application ERP solution provider in the world. And a lot of companies are really running SAP and depend on SAP. So what do these customers do? Just some examples so you get some figures about the value of SAP. So they transport 1.1 billion flight passengers per year. I don't want to read all of that, but it's really a lot of things that they're doing. Big car producers run SAP, entertainment companies, Warner Brothers, Disney. And most important of all, because, yeah, of course, who cares about flights, cars, and stuff like that? But something we all care about, or most of us care about, is that 72% of the world beer production depends on SAP software. So this is at least one reason to protect SAP systems and make sure they're really protected. So, yeah. Okay, now this is a little interactive Q&A. Some numbers. What do you think on an SAP basis tree? So first of all, SAP comes with a basis version, which is the technological foundation, where you can do user management, where you can develop and do stuff like that. And on top of that, you have business solutions. In this case, we refer to ECC 6.0. This is a business solution. So some questions about how many database tables do you think exist in a standard sub-basis installation, a plain basis installation? 200, thank you, the gentleman on the top. Who asks more? 300, thank you, the sir on the left side. Let's make an auction out of that. Anyone more than 300? 301? Yeah, more is not a number, sir. 600, thank you very much. 27,000, a bold statement. Okay, that's not that. 30,500 VB tables. How many lines of code do you think exist in a sub-basis? Huh? 20 million. 50 million. 37.9. Which is quite a lot. And how many executable programs do you think exist in the standard? You don't have to write. It's there when you install it, approximately. 200? Thank you. Somebody says 300? 35,000 basis stack. So now we go to the next level. How many database tables do we have in an ECC 6.0 system running solutions like financial, HR, and stuff that companies really need? Because with a basis stack, you basically can't do anything if you're an organization unless you want to build all your applications yourself. So how many database tables do you think are there in the full-blown enterprise stack? It must be more than 13,000. 13,600. A good idea. Any higher number? Okay. 97,000. So basically in SAP, all the data are in the database. So there are really a tremendous number of database tables there. And now let's go through the other numbers a little bit quicker so we don't waste too much of your time. Lines of code, 172 million. Apple macOS has 85. The Linux stack has 15. So this is really a high complexity. And executable programs, as anybody would have guessed, are also a little bit more than we had before. So what we have here is just an idea of the complexity of the system and also an idea about the masses of data that are in a system and the masses of business logic that exist in an SAP system. So there are really a lot of things you can do in SAP to manage your business processes. So here's a picture on how the architecture is when users log on or work with SAP. So they use an application called SAP GUI, which is a proprietary solution with which they can connect to the SAP server and then connect specific SAP application servers here in the back and interact with them. So that's the way people are used to work with SAP. So yeah, this is a picture of SAP GUI, just to give you some idea what it looks like, because this is a technology we are using to perform the attack later. So who works with that technology? Every employee of a company, of course, because they want to run business. They need SAP GUI to do, create sales orders, purchase orders, to create HR records, to assign salaries to people. Basically, everything you do in a company, you can do with SAP GUI and run any of the many SAP programs that are in the system. So who also works with SAP GUI? Administrators, because they use the exact same tool to maintain the configuration of the system. To do user maintenance, assign roles to users and stuff. And also, last but not least, even the developers that write custom SAP applications use the same application, SAP GUI. They just run different applications with it and can write code. So, in short, we have a wide variety of users that use this technology with totally different privileges and things they need to do in the organization. Yeah, and still most backend access is done with SAP GUI today in organizations. Okay, a few more words on the technology itself. It's a proprietary fat client. It has a lot of functionalities. On Windows, it's an exe file. There's also a Java version. It has potential to access the client operating system, the file system, and stuff like that. So it is really powerful. It's also scriptable. And it uses also a proprietary communication protocol to communicate with the backend. And all the upload and download of files can be done with SAP GUI. And of course, all the data you need to send to the backend and display from the backend are also channeled through this protocol. So this solution is really powerful, and every user, every business user in an organization that runs SAP uses it for the day-to-day work. So I don't know how many of you were already in Mariano's talk earlier today about forensic. We quickly reiterate some of the things Mariano already explained. Basically, there are some important security things you need to consider in SAP. Roles and authorizations are one important part. You need to make sure that the business users can only do the things you want them to do. So you need to restrict their access to specific programs or to specific data Usually, you restrict access to business logic, to programs, and thereby control who can do what. Another important aspect is accountability. If there are financial transactions involved, I must have a clear record of who did what, when. You can't have an entry that says $50 million have been transferred and you have no clue who triggered this. So this must all be accountable. So basically, there are changes to relevant data can be logged, as well as you can have information who accessed the database, did people have the right authorization, who executed which program when. And another part, which in SAP is also relevant, you can host multiple businesses on the same system. And there's a mechanism called clients, which is there to separate the data of the different businesses hosted in the same system. So just to make sure that if you are part of client 42 over here, that you cannot access data on any of the other clients. This is also an important mechanism in SAP. So you now have sort of a basic idea of the complexity and things that exist in an SAP system. So about forensics, there are very few monitoring tasks that are active all the time by default on an SAP system. You can switch off, of course, many monitoring solutions by SAP, but they usually tend to consume a lot of disk space if you do so. That's why many companies don't activate all of them. So especially, there's a very prominent one which is called the security audit log. And the security audit log is a monitoring solution that basically checks who logged onto the system, which logons failed, was a user created, was a specific program started, and stuff like that. And there's also another one we want to show today, the system trace, by which is usually not turned on because it really consumes a lot of data, by which you can check authorizations of the users. If you run a certain program, which we will see later, did the user have the right privilege to do that? And if they access the database, which tables did they access, and so forth. OK, now let's go to phase 2 of our project, Ghost in the Shell. And now we switch over to a demo. In order to do that, Xu will play the part of the attacker. He does it very good. And he is, by the way, the person that found the vulnerability we are now demonstrating.
Okay, thanks, Andreas. Hello, everyone. My name is Xu. Just mentioned by Andreas. I firstly want to show you how to activate the system trace and the security audit log. So let's log into the system, ABAP system. The password is, it's wrong. Okay, so let's go into the SE38. Let's start a short program. I just prepared a small program. Sorry, I'm not recognizing this. Better? Yeah. Okay. Okay, I just prepared a little ABAP report. What we see is here is an authority check and a database access is done. So if we activate the system trace and the security audit log, we expect that at least the authority check and the database access is then logged. So for the security system trace, we go to the transaction ST01. So just active authorization check and database access. So then we can use trace on. So we need another for the security audit log. We can activate it. Activate audit. Okay, so now let's execute the report. Says the report is executed. So for the security audit log, we need to go into the transaction SM20, the date, time, thing, read audit log. Okay, what we see is the user, myself, and execute the report, the troopers log, yeah. The report is started, it's logged. And we check the system trace. There's more information in the system trace. We just go down to the system trace. I hope I can find it again.
As you see, there's really a lot which is protocol. If you switch that on, we're just 2 users currently working here.
Hope I can find it again. Yeah. Okay. So you will see the user is myself, JERX. So ST code is the authority check we did. Sorry. ST code and user 02 is the database access we did. So it showed you that, as expected, all things I did is really logged in the system. So now let's start the real attack. For the real attack, we need another laptop. So Andreas will help me.
So I'm now another user on the same network logged onto the same SAP system with a different sub-GUI on a different machine, separate.
Yeah. So let me just check. Okay, I'm the attacker. That's my name. Yes.
So wait,
okay.
I have to switch on the log, right?
Yeah.
Okay, so now we do the same thing that just Shu did. Oops. So we again create a trace. This time just the authorization trace because this is not as much stuff as we saw before. Okay, now I put it on. And I step away from the machine and do nothing.
Okay.
Did you notice that? That's the same program Shu started on his machine earlier. I didn't do anything, it just came up. Now I close that. And now I want to stop the trace and see what's going on. And now it tells me, this is my user, up there, Wiegenstein. Down there, there's an ST code check. And my user is in it. So what has happened? A program, Shu launched the program under my account on my machine. And I didn't do it. And the log says I did it. But I was standing here like that. And I told you earlier, in an SAP system, it's crucial that you have accountability. With this kind of funny thing, you can make somebody execute a business logic they didn't do. And we showed earlier that there are really a lot of standard executable programs in the system, which means Shu could now trigger a malicious business program, which would, for example, make me fire another user. And everybody, if they look in the logs, would say, hey, you did that, well, while I didn't do it. I didn't touch the machine, and still the program got executed. And the log says it was me. We can also check, or double check, what the security audit log says. So where was that? Yeah, here, you see it? ztroopers log. The security audit log says, I started that. It names the time, date and time. It says also on which machine that happened. And I did that through transaction SE38. And it's in the log. So every auditor that checks the security audit log will say, hey, guy, you actually did that. You launched that report while I didn't do it. So what does that mean? It means this mechanism, this ghost mechanism, which does some magic things in the SAP system, can be used from one sub-GUI to attack active sessions of other users. And this is totally under the forensic radar because the forensic says different. It says, I did it, not you did it. Okay, but I hand back to you. We have some other nice things to do. So this attack is clearly something that affects the business logic. You can, with that, users that have high privileges, which you do not have. Maybe Shu doesn't have the privilege to run specific reports that transfer money or create users. But with that, he can make me do it, another user with the privileges to do that, although I didn't want to do it. Okay.
Okay, let's start the second demo. Okay, what I want to do here is just open a browser. So I will do for myself. Check the browser opens and the Troopers website is opened. It's quite simple.
Sold out. Cool.
Sold out. Okay. What we want to do is to start a browser for another user. So firstly, how can I know which user is also on the same system? So there's a SAP transaction, SM04. So here, an attacker can get the information with who else is on the same system. So I see that currently there's only 2 users. So instead of myself, I can use Wiegenstein Andreas account. Okay, so let's just try it. So if I click the execute button, you must know what happened. What happened?
Browser starts on Andreas' machine.
Left screen, right screen? Left. Okay, from your side. The browser is opened, and the Troopers, the proxy it takes, but it will open.
Yeah. And it's still sold out, damn.
Okay. So let's start another demo. So we just showed that we can open the browser. So I will show you that it's possible to open any command, OS command on the system. What happened? So I just opened the Windows command tool exe, but I not only to start the program, but also giving parameters. So I can start arbitrarily any OS command I like. Yeah. Here is only a ping to the Troopers DE. It's not serious.
It's good that it's still up, so we see that here.
Yeah. But an attacker normally won't leave the pop-up window there. Okay. So before we start the next demo, I need help from Andreas to show us that the ctemp folder is, let's double check that the folder is really empty.
So we have a folder ctemp, there's no file here.
So
Step away from the machine.
Far away further. Okay. What do we see? The file troopers.exe is created from my side, and just did nothing. Yeah, it could be any kind of files like a virus or yes, anything. And we see in the previous demo that I can start any OS command. That means that I could also run this program I created just. So created file, but as an attacker, I don't want to leave any hint, trace in the system. So what I do is just to delete the file again. So you can see I don't not only have read access, but also write access. So yeah, if you have any files on your laptop you don't need anymore, please call me. So, yeah, we need a volunteer for us to help us for the next demo. Any volunteers?
It doesn't hurt. If there are no volunteers, we'll take a volunteer from SAP, so please. Okay.
Hello. Hi.
Hi. Okay, so now you're the victim.
Anyway.
What we're going to do is we're shutting you.
Yeah, it's my laptop.
Yeah,
Don't do any damage.
We'll keep bringing you in the dark. So and you're.
Yeah.
No.
I just
Wait, that was way too early. You're right, Shu. Sorry. What I'm going to do now is I'm asking him to type into an editor the name of his favorite movie and copy that name to the clipboard. That's the task. But you will not see that because we will blank the screen. All I want to do now is I'm starting Notepad so he can type that in. Shu, I can't find Notepad on your system. Can you please open it for me?
Sure.
Thank you very much. Okay, now we can darken the screen. And please type the name of your favorite movie. And, so Shu does not see it. And just copy it to the clipboard, please.
Copy oder nur reicht, oder?
Copy.
If you exit, no one can see it anymore. But okay, thank you.
Okay.
Okay.
Cars. Cars.
Let's have a look. Cars.
With kids, I can already speak aloud. Yeah.
Thank you. And did you notice anything unusual while you did that?
Yeah. It's UpGUI 710. Current is 730.
That's right. Okay. Do we need him anymore?
Maybe
Yeah, right.
another-
There was a second one.
question? Yeah.
Now we know your favorite movie. Can you also type your favorite song? Just to redo it, and can also be a children's song, no problem. So just everybody can see what actually happens on that system.
Okay.
You need to copy it? Did you do it? Okay, thank you. So actually, did anybody notice anything unusual on that machine? You're nodding? It flickered, yeah. But if your machine flickers, what do you do? Very good. You hit it and then it works again. Okay, thank you very much for your assistance.
Yeah, maybe we need another volunteers. That's yeah.
Yeah, right. Okay.
I think SAP is not suitable for this.
It's too easy for somebody from SAP.
Yeah.
Okay, everybody saw that didn't hurt, so someone else? Someone else, just for a minute? Then we need the same volunteer. Find someone else. Ask your neighbor, maybe. Just wait a second. We need somebody. I mean, I can do it as well, but it's more fun when someone else does it.
Anyone?
No one? Okay, great. Thank you, sir. So I'm going to log off again.
Hello.
Okay, thank you. So I'm sharing my user account with you for this demo. The password is Troopers. Can you please log on to the SAP system? Lowercase letters. Yep. Okay, now we act like this is somebody working in an organization trying to do the day-to-day work with SAP GUI. Now, we go to some application, in this case, an application that allows us to write code, but it doesn't really matter which application we're opening. It's just convenient because it's a basis system. So we write an application that Troopers tests. So now here's the screen for you. And now just type in some ABAP code, please. I'm just joking. You could just try some things. And we can see, so you can maybe do a write command. Write, and then something in single quotation marks, hello, troopers or something. Thank you, and single quotation marks again, and a dot at the end. Okay, now, so this is your first ABAP program. Congratulations, oh, wow. Great. So and now, if we were now to switch to a different program.
I'm not going to charge you like $100 an hour.
Yeah, no, you can. So it notices we are leaving the editor and asks us, do we want to save or not? And we say, no, we don't want to leave the editor. We cancel that. So now we continue our work. We try something else. Maybe we can wrap the hello troopers into a little loop. So maybe you do some like do, and then maybe space, 10, space, times. Oops.
I didn't do it.
I didn't do it.
He didn't do it. Okay, now what happened? Suddenly, you saw before when we tried to leave the editor that it said, do you want to save the changes? And now, boom, it's gone. So if that happens to you, then it's great if you're working because then you can go home. And the application doesn't or it collapsed or whatever. Now we're trying to log on again. So again, I'm a user, and could you please use Troopers again to log in? And we get an error message on the lower side. User is locked. So whatever, you didn't do it right. I saw it. You didn't do it. You tried to write your first.
That was by me.
First program, and so somehow she managed to kill this session, and not only kill the session without saving anything, but also to lock down the user account. So he can't even log on again, which is a nasty thing. Thank you very much for your cooperation.
Thank you.
So this is an ABAP training course. So excellent.
Okay, let's start the demo.
Okay, great, thank you. So so much for the demo. And if you want to avoid this kind of issue, this is a sub-security node you should have in your system. And as you can see, we were very kind with the release of that. It has been fixed already a long time ago. So it should be on every SAP system now. And this kind of attack should not be working anymore. So this is what we used. We didn't attack the data transmission between the system, between the sub GUI and the backend, and somehow inject malicious stuff. No, we didn't do that. We used the functionality of the SAP application server to send commands from one station to another and execute them in that station, making the other station look like they were triggered from there. And there's also some advisories that are necessary in order to avoid the possibility that somebody executes OS commands through sub GUI. And the hint was very kind. There's an older sub GUI version that was not protected against this, but SAP released a sub GUI 720, which had a protection against execution of OS commands and creation of files and stuff like that by informing the user, hey, somebody just wants to create a file in your system. Do you want that, yes or no? They brought that in, but again, Shu, the nasty guy, hacked that mechanism, and these nodes are there to fix the sub-GUI version, and so it's protected again. So now let's talk a little bit on how did that work, what we just have shown you. We don't need that one anymore. How did that work? So basically, most of you, probably all of you know cross-site request forgery, which is an attack used in web browsers to plant an attack. Somebody comes on a malicious server, and then it fires into the active session of the web browser. This is a widely known attack. It's even in the OWASP top 10, or it has been. I don't know if it still is. And this is an example of what we call a passive request forgery attack. So basically what it needs to have a trap. We need to plant a trap and wait for another user to come, stumble into the trap, and then we can hit him. And another one that was built based on a trap was a cross-application request forgery attack we showed in Troopers 2011, again related to sub-GUI. But now what we've witnessed today, and this is something new at least in the SAP world, is an active request forgery attack, where we don't have to plant something and wait for a user to stumble over it, but we have an active user session and we can attack it in real time. We can see what is the user, what users are logged on, we can pick any of them and send commands in their system, and in the protocols, in the logs of SAP, it will look like the other users did that. And we can also use that attack, as you have seen, to distribute malware once we have hacked an SAP server to clients in an easy way, to all active clients. So again, the asynchronous, the passive request forgery, here's how it works. You found some vulnerable system, then you plant an attack on a web server. The next thing you have to do as an attacker, you have to wait and try to trigger some social engineering stuff, or simply be patient till somebody comes across the server by accident. And what then happens? We have a user that is connected to a web session, to a legitimate web session, maybe something like eBay or a Google account or a bank account, and then he comes across the malicious web page, and the trap is here, and it launches through the browser and attacks the other web session. But with a synchronous attack, we have a number of users that are currently logged on to SAP systems. One of them is malicious, and he sends a command through the backend to any of the users and can attack them at will in real time, which is a very bad thing in an environment where you heavily depend on authorizations and on accountability. So to summarize, make sure you always have the latest SAP patches installed to be sure that there are no problems like that on your system. And also make sure that your custom code does not do anything malicious here, because in order to launch the attack earlier, we needed to build some little custom reports that triggered this. So to make that clear, the mechanism was not there in the SAP, and I could do some magic and it worked. I needed to write a small program to launch the attack. And I needed to know how to do that in order to make this exploit. So the SAP system in itself, if you install it, has the technical capability of doing it, but nobody knows how, and there's no business logic to execute it. We built that ourselves, and you have to make sure that there is no such program that can leverage mechanisms like that in the SAP system. So if you need more information on SAP security and especially application security, here are some links you might find interesting. And if you have any questions, including other programming, about ghosts or something like that, now is the time to ask.
Questions? Where's the download link for the code?
We do not show that. You can ask Shu if he wants to join you for dinner. Maybe he tells you something.
Okay, no questions?
No questions, thank you very much.
Oh, wait.
Last minute question, thank you. You also want to come down and write some other programs?
It seems like you did the attack on when you were logged onto the same application server.
Yep.
Does it also work if you're on different application servers?
Yes.
Thank you.
bad
A
question.
very, very valid question. Yes, it works. It works on others. But of course, you need certain conditions. I need to have a way to get from application server A to application server B, and then I can attack everybody in application server B as well. Yeah, that's possible. Other questions? Okay,
Doesn't
great.
look like.
Thank you
So-
very much.
Thank you very much.
Thank you.